Hello everyone, very good morning. Let me know that sound quality, picture quality, everything is fine. Very good morning. This is a very important subject, network or circuit theory. Today's topic is what KCL and KVL, that is Kirchhoff's current law, Kirchhoff's voltage law. Okay, and we will solve number of important numericals. तो होप आपने सबने असाइनमेंट्स पूरा कर लिया होगा, कर लिया कि नहीं? यस और नो? यस, ओके डन. तो चलिए, दैट इज नेटवर्क थ्योरी लेक्चर 4 KCL एंड व्हाट KVL, किरचॉफ्स करंट लॉ एंड किरचॉफ्स वोल्टेज लॉ. तो आई एम गोइंग टू टेक 1 or 2 जनरल सेशंस ऑन YouTube, तो यू कैन वॉच, यू कैन अटेंड सेशन के हाउ टू क्रैक दिस एग्जाम्स इसरो एंड देन फर्दर दैट व्हाट अदर कॉम्पिटिटिव एग्जाम्स लाइक गेट एंड देन व्हाट इंजीनियरिंग सर्विसेज एग्जामिनेशन एंड सो ऑन. तो तीनों सबका सिलेबस, टेक्निकल सिलेबस ऑलमोस्ट सेम है. गेट में थोड़ा अलग है, न्यूमेरिकल इसमें थोड़ा बनाने का पैटर्न अलग है, और इंजीनियरिंग सर्विसेज का तो प्री मेंस एंड इंटरव्यू 3 स्टेजेस में. तो वो आप लोग बस रेगुलर रूटीन फॉलो करो, यू कैन क्रैक ऑल कॉम्पिटिटिव एग्जाम्स, राइट. तो आपको बस थोड़ा सा अपना रूटीन फॉलो करना है, स्ट्रिक्ट थोड़ा सा रूटीन बनाइए, टाइम टेबल बनाओ, अपना शेड्यूल बनाओ, प्रीवियस ईयर क्वेश्चन सॉल्व कीजिए. आई थिंक यू हैव डन ऑल योर होमवर्क, यस और नो? अटेम्प्ट किया या नहीं किया, बनना नहीं बनना इट सेकंड मैटर है. अटेम्प्ट किया या नहीं किया, यस और नो? बहुत सारे न्यूमेरिकल्स मैंने आपको दिए हैं, आज सॉल्व करेंगे. देन तो चलिए स्टार्ट करते हैं. नेटवर्क थ्योरी, KCL एंड KVL, लेक्चर 4. दिस इज माय इंट्रोडक्शन. Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks. And I worked as deputy director in Ministry of Power. Then I have resigned and I have trained more than 1 lakh students. Okay, and these are my areas. You can also join my Telegram channel through this link. And this is instruction for students. Again, I am repeating. हर बार मैं repeat करता हूँ, लेकिन ध्यान रखिएगा, अभी भी आप टेबल पर बैठिए. प्लीज यूज टेबल एंड चेयर, राइट. एंड देन पेन, नोटबुक, कैलकुलेटर अभी नहीं, वर्चुअल कैलकुलेटर चाहिए होता है. रेगुलरिटी एंड पंक्चुअलिटी थोड़ा मेंटेन करो, और ये तो आप बिल्कुल स्ट्रिक्टली फॉलो कर रहे हैं, नो प्रॉब्लम. अगर क्विजेज हो रहे हैं तो डेली क्विजेज दीजिए, अटेम्प्ट क्विजेज डेली, एंड स्ट्रिक्टली फॉलो द डे वाइज स्टडी प्लान. ओके, देन तो ये इंस्ट्रक्शंस ध्यान रखिएगा. अब आते हैं भाई, नोड क्या है, ब्रांचेस क्या है, लूप्स क्या है. नोड की स्पेलिंग गलत हो गई यहां, नोड. What is node, what is branch, and what is a loop, guys? Okay, then you can understand the KCL and KVL, Kirchhoff's current law and Kirchhoff's voltage law. Okay, तो स्टार्ट करते हैं. देखो, there are 2 important laws. One is what KCL, Kirchhoff's current law. Another one is what KVL. So we have idea about that from 11th, 12th. We are solving that in a 12th class. We are solving the questions in a entrance examination for engineering, like what JEE, mains, advanced. We are solving the question based on that. No, right? But we have to get the command over that. And what are the use of this? In interview, they will ask question based on what KCL and KVL. Simple. So what is meaning of the branch? A branch represents a single element such as voltage source or a resistor. For example, this particular branch, it is a 1 branch, 2, 3, and what 4 branch, right? 1, 2, 3, and 4 branch, because one battery we are considering it as a branch, one resistor we are considering it a branch. This resistor we are considering, this resistor we are considering. So there are 4 branch. Okay, 4 branch. When I am talking about the node is the point of connection between the 2 or more branches, right? So in this case, this is the branch, these are the nodes. Okay, because in between these 2 nodes, one branch is connected, then one branch is connected, one branch is connected, one branch is connected, but it is a common node. In between there is no element like resistor or capacitor or what, battery. So watch this. A node is the point of the connection between 2 or more branches. And what is the meaning of the branch? Short circuit is not a branch. Short circuited path is not a branch. What is the meaning of the branch? Which has a voltage source or a resistor or any particular element like inductor, capacitor. So here there is a no element. That's why these two are common node. These two are common node. These two are common node. So this is a single node, one node. Similarly here there is no element. So these all are what? Single node. So in this particular diagram, 1, 2, 3, 4 and 4 branches and what? 2 nodes, guys. 4 branches and 2 nodes. Then loop. We are using the different terms. A loop is any closed path in a circuit. Any closed path in a circuit. So when we will understand the mesh analysis and what super mesh analysis, that is a different story. But what is the loop here? For example, watch this diagram. Now this is the loop, closed path. So this is a loop. This is also a loop, closed path. This is also a loop. This is also a loop, closed path, right? And independent loop, 1, 2, 3 independent loops. So these are the loops. Any closed path. Loop is any closed path in the circuit. But when we are saying that independent loops, independent loops means like this. So any closed path is called what? Loop. Then watch this carefully. This is the first one, right? Then this is the second one. This is the closed loop. Then this is the third one. First, second, and what? Third. Okay, these are called what? Any closed path. Any closed path is called what? Loop. We can apply the KVL, Kirchhoff's voltage law, in any. We can apply the Kirchhoff's law in this loop. We can apply the Kirchhoff's law in this loop. We can apply here. We can apply here. We can apply. We can merge these two loops. So KVL, just to apply the KVL, closed loop is required. But when we are talking about the mesh analysis or independent loop, these are called 1, 2 and what? 3. So this is the node, single node. There are 2 nodes, 4 branches. Okay, 1, 2, 3, 4. 2 nodes, right? And independent loops are 3. First, second and what? Third. Is it clear, guys? Everyone, that is clear to you? So in a graph theory, remember, at the end I will give you the idea about the graph theory. So you will understand what is the meaning of that, what is the number of branches, number of nodes, number of loops, and cut shed schedule, tie shed schedule, number of trees, okay, chords. तो ये सब आएंगे इन अ ग्राफ थ्योरी. अभी आज हमको समझना है independent loop. Once again, independent loop, yeah, sometimes we are called what? Mesh. Mesh means what? For example, it is given here. One minute, I want blank page, no? Okay. This is the independent. For example, this is the one loop. This is the second one. And this is the third one. right? We are considering it as a 1, 2, 3. So we can apply, we can consider the three mesh currents. So in a mesh analysis and nodal analysis, we can understand this is the I1, this is the I2, this is the I3. So for this particular loop, what is the current I1? For this particular loop, what is the current I2? For this particular loop, what is the current I3? These are called what? Mesh current. So how many? 1, 2 and 3. Right? Same thing. But when we want to apply the KVL, we can apply the KVL from this. We can consider the three elements V, R1 and R2. We can apply the KVL V, R1, R2 in this loop. Or we can apply the KVL between what? R2, R3 and R4. R2, R3, R4. This is a loop. Or what? R4, R5, R6. First, second, third. So this is what loop or mesh. So normally we are counting this 1, 2 and 3. We are applying the KVL. But we can apply KVL in any closed loop. For example, this is also a closed loop from this point to this point. So it is a closed loop. We can apply the KVL between what? V, R1, R3, R4. We can apply the KVL R4. For example, we can apply the KVL in outer loop. It is also possible. V1, R1, R3, R5, R6. So what we are doing, actually we are merging the loops 1, 2 and what 3. We are considering all as a single loop. Right? When we are writing the KVL from this point to this point, actually what we are doing, we are connecting these two loops. Is it clear now? So we will solve more question. You will get more idea about that. Don't enter into the definition of that. No one is going to ask you the definition. Okay, no one is going to ask you the definition. We have to solve what? Numericals. Okay. Clear? We can say. Which one? V1, R3 and R4. V1, R3 and R4. How is it possible? V1, R1, R3, R4 is a loop. But actually what we are doing, we are merging these two. And that's why it is not a, we are in an equation, we are not counting as a loop. Otherwise in this question, how many loops? Tell me. Otherwise in this question, 1, 2, 3, 4, 5, 6, right? And so on. So, right, we can apply the KVL in any closed path, but when we are talking about the equations, how we find the mesh, how many mesh equations is required, how many nodal equation is required. So for that, number of branches, number of node and number of loops. So in this formula, how many loop? 1, 2, 3 only. Is it clear? We can't use like that 1, 2, 3, then 4, then 5, then what? Complete loop 6. No, like, okay then. Fine, numericals, we will solve more numericals on that. So first of all, a node is the point of connection between two or more branches. Branch represent a single element such as a voltage or resistor. So new students, all the students join. So here ask them to join and everyone try to attend the live classes. Then guys, तो अब आते हैं जरा किरचॉफ्स लॉ. देखिए ये तो खैर यू कैन गेट द आइडिया अबाउट दैट. किसने दिया? दैट इज अ साइंटिस्ट इन 1824 to 1887. A German physicist stated two basic laws in 1847 concerning the relationship between the currents and voltage in an electrical network. That will motivate you. अगर ये आप देखते हैं ना तो आपको लगेगा ये यार ये देखो 1824 और 1887 कहाँ जाके ये इन्होंने लॉज लिखे. अभी हम इसरो में जा रहे हैं तो आप एक्चुअली साइंटिस्ट बन रहे हो, तो आपको ये प्राउड फील होना चाहिए कि बस पैसे तो आएंगे ही, आपकी जॉब लग रही है, सिक्योर जॉब है, लेकिन साथ में ना आपको एक मौका मिल रहा है कि आप स्पेस साइंस में कैसे वर्क कर सकते हो. तो ये इसीलिए, अदरवाइज नो वन इज गोइंग टू आस्क यू. तो यहाँ पर देखो आपकी भी फोटो लग सकती है, आपने भी कुछ लॉ बनाया तो आपको भी लोग पढ़ेंगे आगे जाकर. तो ये है किरचॉफ्स लॉ. तो इसने क्या किया, मिक्स कर दिया विद व्हाट, ओम्स लॉ. व्हाट इज द ओम्स लॉ? आई इज इक्वल टू व्हाट, वी बाई आर. तो दिस इज द, तो वाज दैट इज द, अब क्या है दो वो देख लेते हैं हम लोग. तो फर्स्ट है व्हाट, किरचॉफ्स करंट लॉ, KCL, किरचॉफ्स करंट लॉ. तो वेरी वेरी सिंपल. This is based on the law of conservation of charge. Law of conservation of charge means charge can neither be created nor be destroyed. Okay, so on the basis of that we can say the algebraic sum of the currents entering into a node is what, 0. Right? For example, at this point what are the incoming currents? I1 and I2 are the incoming currents. And what are the outgoing current? I3 and I4 are what, outgoing currents. So sum of the incoming current is equal to what, sum of the outgoing current. This is the simple Kirchhoff's law. तो आप इसको ऐसा समझ लो कि जैसे ट्रैफिक है, ठीक है ना, like this. For example, two cars are entering from this, three cars are entering from this. This is the path, right? So how many cars at the junction? 3 plus 2, 5. But it is not possible to reside here. You have to move from this. So when it have to move from this, then so tell me, if the one car is moving here, so how many number of cars in this path? Tell me. Suppose the two car is moving from that side, three cars is moving from this side inside, and one is outside. So how many cars are moving in this direction? 4. So that is a simple thing, just like a KCL. This is the KCL. That particular node charge can't reside. So what will happen? So when we are applying the nodal analysis at this junction, so what is the incoming current is equal to what, outgoing current. वहां रह नहीं सकते, आप आ रहे हो, मूवमेंट कर रहे हो. तो ये हो गया, चार्ज कैन neither be created nor be destroyed. तो incoming is equal to outgoing. That is the one way to write the KCL. Second way, you can choose the incoming current as a positive and outgoing current as a negative. Then we can say the sum of the current is equal to 0. It is also possible. At sum of the current at particular node is 0. So incoming we are taking the positive, outgoing we are taking the negative. Or you can take what, outgoing positive, incoming negative is equal to 0. So all are same thing. 1, 2, 3. Sum of the incoming is equal to sum of the outgoing. So ये है simple Kirchhoff's current law. Important thing, it is based on law of conservation of charge. Law of conservation of charge. Okay. So this is the case. Then second thing is what, KVL, Kirchhoff's voltage law, guys. Kirchhoff's voltage law. Now it is based on law of conservation of energy. तो ये क्वेश्चन है इंपॉर्टेंट, ये आ चुका है, तो ये ध्यान रखिएगा. It is based on law of conservation of energy, KVL. It states that algebraic sum of all the voltages around a closed path or a loop is what, 0. Around a closed path or a loop is equal to what, 0. Algebraic sum of that. Okay. So the sum of the voltages drop is equal to sum of the voltage rises. So okay, because of that voltage will increase. Because of that there is a voltage drop across this resistor and so on. So KVL, when we want to apply the KVL, this is a resistor let. Okay, for example, the supply voltage is V. This is the resistor R1. The voltage across this is V1. Voltage across this is let V2. This is the R2. This is the voltage across this is R3, V3. Then it's up to you. Suppose I'm just giving you all the general formula for KVL now. For example, if you are writing the KVL, the sum of voltage across this loop should be equal to what, 0. तो So we can start with the negative. For example, it is negative. I am moving in a clockwise direction. Normally we are moving in the clockwise direction, but you can move in an anti-clockwise direction also. So this is the minus. This is the minus. So you can write like this, minus V. This is the plus and minus. So this is the plus V1. This is the plus V2. This is the plus V3 is equal to what? 0. This is a KVL. Yes, it is correct. Check the polarity. Minus, this is the minus, then plus. You are entering from the plus, leaving the minus, entering from the leaving the minus, entering from the plus, leaving the minus, and that's why this is the minus V, V1 plus V2 plus V3. This is the correct one. Second, you can take the negative as a positive. So it is a minus, we are getting the minus, you can take it plus, then it has become minus V1, then minus V2, then minus V3 is equal to 0. Again same thing. We are getting the same equation, right? V1 plus V2 plus V3 is equal to what? V. V1 plus V2 plus V3 is equal to what? V. So you are taking it as a plus, you are taking it as a minus, minus, minus. Or what you can directly write, what is the applied voltage V? Some students are writing like that. What is the applied voltage V? That is the rise in voltage. And what is the drop? V1 plus V2 plus V3. So directly you are writing like V is equal to, this is a source voltage, and that is equal to what? V1 plus V2 plus V3. So after practice you can write. You can write. Okay. कितने लोग हैं हाथ छोड़ के गाड़ी चला लेते हो? बताओ. साइकिल चलाते हो हाथ छोड़ के? Yes or no? यार any vehicle we are just छोड़ दिया आपने हाथ और चला रहे हो गाड़ी? Not at all. Right? कभी नहीं. अरे बाद में जब प्रैक्टिस हो जाती है तो मोबाइल में बात करते हुए गाड़ी चलाते हो कभी? आफ्टर प्रैक्टिस. और कितने ऐसे हैं जो फर्स्ट डे गाड़ी चला रहे थे, फर्स्ट डे साइकिल सीखने गए और हाथ छोड़ दिए? इज इट पॉसिबल? नो. तो जब आप प्रैक्टिस करते हो ना, बहुत ज्यादा प्रैक्टिस कर लेते हो, तो चाहे ये लिखो, चाहे वो लिखो, चाहे ये लिखो, इट डजंट मैटर. तो you can use this formula, that formula, this formula, or directly you can solve, but it depends upon your practice. फर्स्ट डे लेकिन एक्यूरेसी मेंटेन करना है, फिर धीरे धीरे प्रैक्टिस के बाद आपको स्पीड मेंटेन करनी है. याद रखिएगा यहां पर स्पीड और एक्यूरेसी का खेल है. और ये आती है किससे? QPM. यू हैव टू चेक क्वेश्चन पर मिनट, हाउ मेनी क्वेश्चंस यू आर एबल टू सॉल्व विद इन 1 मिनट. ओके. तो ये आपकी स्ट्रेटजी होनी चाहिए कि कैसे स्पीड बढ़ाते जा रहे हो विद एक्यूरेसी. ये इंपॉर्टेंट है. देन is it clear now? So this is the KVL. We will solve question and you will get more idea about this. So this is the first question on KCL and KVL. Obtain the node voltages in the circuit of figure. What are the node voltages? So we have to apply what? KCL, Kirchhoff's current law. What is the node voltage at V1 and what is the node voltage at V2? This question is visible to you. You have to find the V1 and V2. I am giving you the 2 minutes. Start solving this question. देखो मैं आपको बता देता हूँ. 3 एम्पियर करंट सोर्स, 2 ohm, 6 ohm, 7 ohm, 12 एम्पियर करंट सोर्स. Apply the concept of what? KCL at this point, and then give me the answer. Now this is the question. Now all the students please focus on the board. और जो भी आपका आंसर आया आप बताइए. देखो जरा. First of all, when we want to apply the KCL here, so there are, this is the one node, we have to find the voltage at this node V1 and voltage at this node, like this is the V2. Now here from this node, this is the ground reference node, let this is the current I1 and let this is the current I2. So these are the outgoing current, and what about this current? Incoming current at this node, and these are the outgoing current. You can write the incoming current is equal to what? Sum of the outgoing current. Incoming current is equal to sum of the outgoing current. So you can get one equation here. What is the outgoing current? V1 minus 0 by 2 तो V1 minus 0 by 2 plus V1 minus V2 by 6. V1 minus V2 by 6. Okay, now you can arrange it. You can take the LCM as a 6, then it will become 3 is equal to, let the LCM is 6, so this will become 3V1 and this will become plus V1 minus V2, right? Then this will become 3V1, 3, and this will become 4V1 minus V2 is equal to what? 18. That is the first equation. That is the first equation. Then second equation, remember when we are focusing on the second equation, when we are writing the equation, always remember, just consider this current, like this is the Ix. What is the outgoing current? Ix. What is the outgoing current? Iy. What is the outgoing current in this branch? Iz. 12. So always consider like that. So you can directly write the KVL here. Outgoing current is what? Ix. No doubt I1 is equal to minus Ix or Ix is equal to minus I1. But consider at this node what are the outgoing current? Ix, Iy and what? Iz. So when I am considering, to what are the sum of the outgoing current is equal to 0. Sum of the outgoing current is 0. Now remember, confusion. When I am considering the I2 from this point to this point, so I am writing the V1 minus V2 because the current will flow from higher potential to lower. So V1 minus V2 by 6, just I am writing V1 minus V2 by 6. But when I am considering the Ix, it is moving from V2 to V1, and that's why write V2 minus V1 upon what? 6. V2 minus V1 up is equal to 6. Iy, V2 minus 0 by 7. V2 minus 0 by 7. This is the 0. This voltage is 0. And what is the outgoing current? 12 ampere plus 12 ampere. All are outgoing, that is equal to what? 0. Now you can take LCM 42. This will become 7V2 minus 7V1 plus 6V2. This is 0 plus 42. 12 into 2, 24. 48 plus 2, 50. 0. Now this 42 will become 0, and then you will get 6 plus 7, 13 V2 and 7 V1. So what is the second equation? Then the second equation will become 7V1 minus 13V2 is equal to 504. This is the second equation. Now we have two equations and two unknowns. Okay, चलिए निकालते हैं जरा. कुछ भी प्रॉब्लम हो तो बताइएगा. Is it clear, guys? How to write the equation? Because once you will get the equation, it will become very easy to solve. So one student is giving the answer minus 6 and minus 42. One is given there 16 volt. One is giving what? 6 and 42 volt. So okay, I will check. चलो देखते हैं ना. आप लोग सभी बनाओगे तभी गलतियां पता चलेगी. नेटवर्क मीन्स ट्राई टू सॉल्व न्यूमेरिकल्स. सिली मिस्टेक्स होगी, सॉल्व नहीं करोगे आंसर नहीं आएगा. तो हाउ टू राइट द इक्वेशन? इनकमिंग इज इक्वल टू आउटगोइंग्स. I am considering I2 here, that's why I am writing V1 minus V2 by 6, V1 minus V2 by 6. Outgoing V1 minus 0 by 2, incoming 3. Incoming is equal to outgoing. Arrange it, you will get the first equation. Then second equation, again at this node I am considering the outgoing current V2 minus V1 by 6, V2 minus 0 by 7 and is equal to what? Plus 12, because it is also outgoing. So sum of the outgoing current is equal to what? 0. Arrange the equation, you will get two equations. Now these are the two equations, guys. Okay, 7V1 minus 13V2 is equal to what? 504. Now you can multiply this equation by 13. So बताओ भाई, 18 इंटू 13 कितना होता है? वैसे तो मैं निकाल सकता हूं, चलो निकाल ही लेते हैं. Am I correct? 18 into 13 देखिए यार, कैलकुलेशन अब क्या, एज होने के साथ साथ कैलकुलेशन ही ना कमजोर हो जाती है, वेरीफाई करना जरूरी है। ओके, अब ये हो गई, दिस इज द सेकंड इक्वेशन, दैट इज द थर्ड इक्वेशन। नाउ थर्ड में से अब ऐसा कर सकते हो, सेकंड माइनस थर्ड, तो सेकंड माइनस थर्ड करोगे तो आपके पास वैल्यू आ जाएगी। तो दैट इज द 52 माइनस 7 मींस इट विल बिकम 45 v1, this cancel out, and then 234 minus 504 guys, तो ये आ गया आपका 270, and then you can find the value of the v1 with the negative sign. What is the 270 divided by 45? 6 minus 6 is the answer. बिल्कुल सही है। -6 volt. Is it clear? This is the answer is what? -6 volt. Now once you have this v1 is equal to -6 volt, you can find the v2. Put in 1. Put this value in 1. So it will become 4 into -6 minus v2 is equal to what? 18. So this is the 24 minus 24 minus v2 is equal to 18. So what is the v2 is equal to? Minus 24 minus 18, and that is nothing but minus 42. Minus 42 volt. Is it clear guys how to solve the equation? You have the command over that. So answer for this question is v1 is equal to -6 volt, v2 is equal to minus 42 volt. Minus 42 volt. Okay. So this is the answer. Now अगर आपको ये मेथड आ रहा है हाउ टू सॉल्व द इक्वेशन, तो मल्टीप्लाई इट and so on, remove 1, and that is the method to solve the equation. Subtract these two equations and you can solve. Otherwise you can use the Cramer's rule also. You can use the Cramer's rule to solve these equations. Matrix, this is the 4 minus 1, this is the 4 minus 1, and what is the coefficient here? 7 minus 13. It is multiplied with the v1 and v2 is equal to 18 and what? 504. So you can arrange in this form, right? This is called matrix form. Then what is the delta? What is the determinant of this? So determinant of this is 4 into 13, that is the 13 into 4 minus 52 minus minus plus plus 7. So this is what? Minus 45. Determinant means this multiplied with this multiplied with this, so you become a minus 13 into 4 minus of minus 7, so it will become that one, minus 52 plus 7 minus 45 determinant. Then if you want to find the v1, so you can find the del 1. Del 1 means the first column 4 and 7 is replaced by what? 18 and 504. 18 504, and this will remain same, minus 1 minus 13. So what is the value of the del 1? 18 into 13, right? 234 minus minus again plus 504. 234 is the minus value plus 504. Then you will get the del 1 is equal to 0 7 270 minus 270 minus, sorry, plus 270 because it is a plus 270. Then what is the v1? Then become v1 is equal to del 1 by del 1 by del. So this is the 270 divided by minus 45, and you will get the answer minus 6 volt. So this is called what? Cramer's rule. So first of all determinant, then second del 1, replace this 4 and 7 by what? 18 and 504. You can get the del 1, that is the 270, and then you can find the value of v1. Similarly you can find the del 2. Similarly you can find the del 2 guys. Just to find the del 2, this minus 1 and minus 13, minus 1 and minus 13 is replaced by 18 and 504. 4 7 18 504. 4, 7, 18, 504, that is replaced. This is the del 2. So what is the del 2 here? Now minus this one. Okay. So this is 2016 minus 126. 1890 plus 1890. So what is the V2 here? Del 2 divided by del. You will get 1890 divided by 45 with negative sign. So 1890 divided by 45, you will get the answer minus 42. Minus 42. This is clear to you, Cramer's rule? So minus 42. But remember guys, once you have by using the Cramer's rule, once you have the value of what? V1. For example, you have the value of V1. Then no need to find the del 2 and no need to find the V2. Directly you can put the V1 is equal to here and you can directly find the V2. So second time, no need to use the Cramer's rule. So once you have the value of V1, you can directly use this formula. Put the value of V1 here and you will get the value of V2. Put the value of V1 here and you will get the value of what? V2 here from this. Is it clear? यहाँ पे रखो ना, वापस रख दो, ये वैल्यू आ गई, क्यों क्या जरूरत है वापस डेल निकालने की, इतना लंबा चौड़ा है देखो. और आप अगर कैलकुलेशन बहुत फास्ट कर रहे हो तो सब इजी है. कैलकुलेशन अगर फास्ट है, प्लस माइनस एडिशन सब्ट्रैक्शन, तब तो कोई प्रॉब्लम ही नहीं है भाई. नेक्स्ट क्वेश्चन. एनी डाउट? भाई सब कमेंट्स करेंगे यस और नो, ऐसा नहीं है कि अकेले वन साइडेड पढ़ा रहा हूं मैं. देखो डाउट्स है तो पूछिए, नहीं है तो यस. आगे बढ़ते हैं सर, गो अहेड. नो डाउट्स? ओके, both the methods are clear, but just because it is the first question and that's why I have given you the idea about what Cramer's rule. So how to solve and how to solve the equations. So I think one student have given the answer 16, no problem. Somik, Harshita, everyone, is it clear? क्या silly mistakes किया वो भी clear हो गया आपको? What was the silly mistakes? Plus minus, why we are getting the wrong answer? Okay then, next. So be careful, try to avoid all the silly mistakes. Normally we are doing like that, minus plus or what, addition, like that. What is the 3 plus 2? 6. This is called this type of silly mistakes. We are doing the sometimes in a multiplication we are doing 4 into 2 7. Quickly we are getting this type of mistakes. We can't avoid it 100%. We can't avoid 100% silly mistakes, right? But we can minimize it. So just this type of mistakes we are doing. 3 plus 2 is equal to 6. 2 plus 2 into 4 is equal to what? 7. In place of minus we are putting the plus, or in place of plus we are putting the minus, and so on. So that is a general mistake, so try to avoid it. Then next one is, for example, this is the question. Find Vx in the circuit of figure. Find Vx. Simple KVL you have to apply with the dependent sources. 1, 2 Vx is the voltage across the 5 ohm resistor, and there is a voltage control voltage source. This is the 2 ohm, this is the 15 volt. And everyone, try to give me the answer, right or wrong, it doesn't matter. If you are not solving, then put randomly any value. Put randomly any value here. One student is given 4.16. Vx is asked, na? Okay. Now watch this. In this case, you can consider one current here, I. That there is a current I. And now, first of all, find the current I, then you can find the Vx. Vx is equal to, when the current enter into the resistor, this is the plus minus. right? Always remember, when the current enter into the resistor, this polarity will become higher polarity plus and this is become minus. It is already plus and minus. Then again the current will enter here, this is the plus and minus, and then so on. So you can apply that KVL. The voltage across this will become I into 1. So this is like, this is the V1. So you can write the V1. This is the V2. And this is the Vx and this is the 2Vx. So KVL we can apply. What is the KVL? This is the minus 15. Remember, avoid the silly mixture. That is the minus 15. This is the minus 15 plus V1. This is the plus minus V1 plus 2Vx. This is the plus minus 2Vx plus Vx you can write, or you can also write 5 Vx. So you can write the Vx. This is the 2Vx. This is the plus minus Vx. Then V2 is equal to what? 0. This is the plus and minus, that's why. This is the minus 15 plus V1 plus 2Vx plus Vx plus V2. Then this equation will become, what is the V1? V1 is equal to I into 1, that is I. Always remember, this is plus minus I into 1. What is the Vx is equal to 5 into I. 5 into I. This is the 5 into I. What is the V2 is equal to 2 into I. 2 into I. Now you can put here, so this V1 will become I. This is the 3Vx, 3 into 5I. Plus what is the V2? 2I is equal to what? 15. This is, so what is this? 15 plus 1 16 plus 2 17I is equal to 5. So what is the I is equal to? I is equal to 5 by 17. Am I correct? Five by 17. Okay, 5 by 17. 5 by 17 or 15 by 17. Yeah, sorry, 15 है ना ये तो. 15 by 17. 15 by 17. Then what is the Vx? 5I. So 5 into 15 divided by 17. Now you can find the value. 5 into 15 divided by 17. 4.41. How many students have given the answer? 4.41. Now I am getting the 4.41. You are getting the 4.16. If there is any calculation mistake? 15 by 18. अच्छा, calculation mistake. अरे यार सीधा सीधा 18 है. मैं वही बोल रहा था, आपने चेक किया कि नहीं किया? देखो ना, 15 plus 2 17 plus 18. तो which mistake? Conceptual mistake or silly mistake? Everyone tell me. This is a conceptual mistake or silly mistake? Tell me guys. What is this? And we are doing this type of mistakes. All calculations are correct. Just we are adding 15 plus and then we are writing the 17. This is what. So you have 5. This is the 6. 25 divided by 6. So that is the 4.16. You can write now. Okay then. Next question. Next question. Now, ready? So, simple KVL. Don't worry. Number of students are worried about what? Dependent sources. So, don't worry about the dependent sources. Just use it like what? Source, voltage source. A voltage source, this voltage source, this is a voltage controlled voltage source, dependent. It depends upon the voltage across the 5 ohm resistor. So, again you can consider it what? Vx. And what is the Vx? 5 times of I. So you can replace the Vx by 5 times of I. And then simply apply the KVL or what? KCL. So don't worry about the dependent sources. Okay, to solve, we will solve 5 to 10 questions. Automatically you will get the command. Any doubt? Any doubt in this question? Anyone? For the network in the figure, find the current, voltage and power associated with 20 kilo ohm resistor. What is the power associated with the 20 kilo ohm resistor, guys? Okay. तो चलिए, अब आप तो सॉल्व ही नहीं कर रहे हैं कोई भी, तो मुझे ही सॉल्व करना है, तो मैं ही सॉल्व कर देता हूं. देखो, for the network in the figure, find the current, voltage and power associated with the 20 kilo ohm resistor. If you want to find the voltage across this 20 kilo ohm resistor, ठीक है, तो this is a current 0.01 V naught, and current, what is the current passed through this? So before solving this question, again I will give you the idea about voltage division rule and current division rule. So first of all, we will understand the voltage division rule and current division rule, then it will become very easy for us to solve this question. ठीक है, what is the voltage division rule and current division rule first of all? Or if you want to solve, then yes, you can solve. Then today we will solve number of questions, but before that, voltage division rule and current division rule, guys. So what is the voltage division rule? Voltage division rule, guys. Now, for example, what is the voltage? Voltage is equal to I into R. So voltage is directly proportional to R if the I is constant. I is constant. So in a loop, this is the resistor, this is the resistor, this is the voltage, this is R1, this is R2. Here the voltage is V1, here the voltage is like V2. Now what about the I? I is constant or I is common for R1 and R2, and voltage is directly proportional to what? Resistor. So in a normal case, what we are doing, we are finding the current V upon R equivalent, and then we can say what is the voltage? V1 is equal to I R1. So we are getting the V R1 upon R1 plus R2. V R1 upon R1 plus R2. Or similarly, V2 is equal to I R2. We can say V upon R1 plus R2 is the current multiplied with the R2. We can directly find the V1 and V2, but we are finding with the help of I, and then we are multiplying. So what is the voltage division rule? It is directly proportional to resistor. That's why suppose the total voltage is V. So what we are doing, V divided by R1 plus R2. How many resistors are there? 2 resistors, R1 and R2. Now if you want to find the voltage across the R1, it is multiplied with the R1. It is a ratio we have to divide. Similarly, V2, V divided by R1 plus R2. Since it is proportional to what? Resistor, and that's why it is multiplied with the R2. This is called voltage division rule. Directly you can find with the help of voltage division rule. So V1 and what? V2. We can directly apply the voltage division rule, because it is directly proportional. So for example, there are 3 resistors. In series, because voltage divided in what? Series. This is R1, this is R2, this is R3. This voltage is divided in 3 parts: V1, V2 and what? V3. Then according to voltage division rule, what is the V2 is equal to? Directly you can find V divided by 3 resistors through R2, then it is multiplied with the R2. Direct answer is VR2 upon R1 plus R2 plus R3. Similarly, you can write the V3 is equal to V divided by R1 plus R2 plus R3 and multiplied with the R3, because it is directly proportional to resistor. So it is called what? Voltage division rule. Voltage division rule, guys. Right? So ये है voltage division rule. Now tell me, just I am giving you the very simple question. Okay, and then try to solve this. Avoid the silly mistake. Now tell me. For the circuit in the figure, find the voltage V1 and V2. ये है voltage division rule का question. Simply बताओ what is the value of the V1 and what is the value of the V2. 20 volt is given, 2 ohm, 3 ohm resistor is given. Tell me, everyone. अरे ये तो बना लो. Yes, yes, everyone. Please participate in poll. 8 and 12, 8 and 12. Good. ये तो बन जाएगा सबसे. अब रे बाबा, what is the first instruction in every exam? Tell me, right? What is the first instruction in every exam? In every exam, there is one first instruction line. What is that line? Read question carefully. Observe question carefully. Watch this. If this is the diagram, right, this is the plus minus, let it is the Vx, plus minus, let it is the Vy. What is the value of the resistor? 2 ohm, 3 ohm. This is the 20. So what is the value of the Vx is equal to 20 divided by 2 plus 3 into what? 2. So this is the 8 volt. Vy is equal to 20 divided by 2 plus 3 into 3. That is the 4 into 3, that is the 12 volt. Okay, no problem. Then your answer is correct, 8 and 12. Is it clear, guys? But watch the polarity here. What is the polarity? This is the plus, this is the minus. Now the polarity is reverse. So what is the value of V1? V1 is equal to Vx, correct. What is the V2? It is a Vy or minus Vy? Everyone tell me. It is the Vy or this is the V1 is equal to Vx, same thing. You have given the right answer. But when we are writing the V2, it is not Vy, it is the V minus of Vy. It is a minus 12 volt. So answer is 8 and minus 12 volt, because in question polarity is reverse. So we are applying the voltage division in this diagram. But be careful, polarity is reverse, that's why it is minus. Is it clear? So you have given the answer according to this diagram, but actually question में minus plus polarity reverse हो गई है. Okay then. तो कोई बात नहीं, वो छोटी मिस्टेक है, लेकिन आइंदा ध्यान रखना. So it is a voltage division rule. Oh, diagram नहीं दिया हुआ. Current division rule. I am just giving you the current division rule. In a current division rule, current is divided when the elements are connected in parallel, guys. For example, there is a current source, and let these are the elements are connected. R1 and R2. Okay, now remember, since the current is equal to V by R, and in parallel the voltage will remain constant. Voltage will remain constant, means current is inversely proportional to R. Current is inversely proportional to R. So what is the current division rule? For example, this is the incoming current Is. It is divided into two parts, I1 and I2. I1 and I2. So Is is equal to I1 plus I2. Incoming is equal to outgoing current. So according to current division rule, I1 is equal to total current divided by resistor. Since it is inversely proportional, that's why it is multiplied with what? R2. Multiplied with R2. What is the I2 is equal to Is into upon R1 plus R2, no problem. It is multiplied with what? R1. It is multiplied with R2, it is multiplied with the R1. A denominator will remain same. So that is a case, guys. This is called what? Current division rule. Current division rule. Okay, it is inversely proportional to what? This value. Now, just I am giving you the simple question. Give me the answer. 15 ampere that current is given. This is the 2 ohm, this is the 3 ohm resistor. Tell me what is the value of this Ix. What is the current through the 3 ohm resistor? 15 ampere current source is given, 2 ohm and 3 ohm. Simply, very simple question. Just I want what is the current through the 3 ohm resistor. 15 ampere है ना? 9? Yes. You are giving the 6. 9 or 6? Inversely proportional. It is inversely proportional. More will be the value of the resistor, less will be the current. More will be the value of the resistance, less will be the current. So for example, 3 ohm matlab means you have to find the Ix is equal to 15 divided by 2 plus 3. If you want to find the current through this, then you have to multiply it with the 2. So 15 into 2, 30 divided by 5, that is the 6 ampere current. Inversely proportional. Okay, 6 is the right answer. Then what is the current through the 2 ohm resistor? Current through the 2 ohm resistor is 15 divided by 2 plus 3 multiplied with the 3, 9 ampere. And total current is 9 plus 6 is equal to what? 15. Everyone, that is clear to you? क्यों भाई सौमिक कुमार क्या हुआ? I have asked the question through what 3 ohm resistor. All are giving the 999. Is now it is clear? जितने लोगों ने भी 9 लिखा है वो बताओ ओके, और अदरवाइज अगर डाउट है तो बताओ क्या डाउट है. ओके 9, हाँ 2 ओम से 9 एम्पियर है और यहाँ 6 ओम है. फॉर 2 ओम इज इट? यस, इट इज करेक्ट. नाउ दिस इज द 6 एम्पियर एंड सो ऑन. नाउ ये तो हुआ 2 ओम. देखो एक समझना जरा इसको. अभी मैं एक और क्वेश्चन देता हूं. आप पॉइंट समझते हैं? ये देखिए जरा ध्यान देना. This is the 6 ohm, 3 ohm, 2 ohm, right? There are 3 resistor, 2, 3 and 6. There is a one current source, okay, 20 ampere, right? 20 ampere is the current, or you can let 30 कर दो, कोई प्रॉब्लम नहीं, जैसे भी बनाना. 30 ampere. Find I1, I2 and I3. I1, I2 and what? I3. I1, I2 and I3. Current division rule for 3 registers. If there are 3 registers, then first of all what we can do, चलो सॉल्यूशन बनाते हैं 2-3 तरीके से. First method, we have the idea about the current division in 2 registers. So find a parallel combination of these two. So what is the parallel combination of 3 and 6? It is the 2 ohm. So 2 ohm, redraw the diagram. This is 2 ohm, this is 2 ohm. And this is what? 30. So because these two are equal resistance, so what is the current here? 15. And what is the current enter here? 15. So this is over. What is the value of the I1? 15 ampere. Now here it is the 15 ampere. Here enter what? 15 ampere. Combination of these two. Now this 15 is divided into what? 3 and 6. This 15 is divided into what? 3 and 6. So what is the current through the I3? 15 divided by 3 plus 6 into 6, inversely proportional to that. ठीक है, 90 divided by 9, that is the 10 ampere. Okay, now what is the current through the 6 ampere? No need to write the voltage division rule. Already it is 15, it is 10, 15 plus 10, 25. So what is the current remaining? 5 ampere. So no need to apply the voltage division rule. You can apply 15 divided by 3 plus 6 into what? 3. So this is the 5 ampere, or otherwise you can directly apply the, this is the 30. So already I3 is equal to 30 minus I1 I2, I1 minus I2. You will again get the answer 5 ampere. So this is a simple way to solve the question. Is it clear? Or Curly Pawan, you are giving the answer 5, 9 and what? 6. Okay, check my calculation. Is there any mistake? Okay. Now normally students are doing different types of mistake. Just I want to give you the idea. So this is the correct one. First of all, find the equivalent of 2 resistor and then divide the current between the remaining 2 resistors and you will get the answer. This is the 5 ampere and so on. I1, I2 and I3. 15, 10 and what? 5. Okay. What we are doing actually, normally students are doing the mistakes like this. Suppose they want to find the I1. So what they are doing actually, total current I divided by total resistor R1 plus R2 plus R3. Normal mistake, R1 plus R2 plus R3 and it is multiplied with what? R2 R3. R2 plus R3. Why? Because it is inversely proportional. So they are just dividing it by the total resistance and R2 and R3. So what is the answer here? Let 30 into 3 plus 6, 9 divided by 2 plus 3 plus 6, 9 plus 2, 11. 180 divided by 11. Wrong answer. Wrong answer. So you can't use this type of formula. It is inversely proportional. That's why we are dividing it and multiplied, because we have to find the current through the R1. This is the wrong method. This is the wrong method. So if suppose you want to use this type of method, then what is the correct one? Yes, watch this. What is the correct one then? Then guys, so this is the wrong one. If you want to this type of formula, you don't want to find the parallel combination of these two. So remember, I am saying that I is equal to V by R. So I is proportional to what? I am saying that I is inversely proportional to R. Yes, word what I am using? I is inversely proportional to R. But I can also say I is proportional to what? 1 by R. Yes or no? I is proportional to, directly proportional to 1 by R. If you are saying that it is directly proportional to 1 by R, what is the R? G, conductance, 1 by R. So we can say I is directly proportional to what? G, conductance. So this is the G1, this is the G2, this is the G3. What is the G1, G2, G3? G1 is equal to 1 by R1. G2 is equal to 1 by R2. Or G3 is equal to 1 by R3. Now you can find the I1 like this. Total I divided by G1 plus G2 plus G3 into what? G1. Why you can write this formula? Directly proportional. Directly proportional total conductance divided by what? Multiplied with the conductance. Just like a voltage division rule in 3 registers. तो यहाँ भी आप करंट डिवीजन रूल में यूज कर सकते हो. अब आपने लिखा I1 is equal to I G1 upon G1 plus G2 plus G3. Now watch this formula. What is the G1? 1 by R1. Because it is proportional to 1 by R1, you can directly write 1 by R1. 1 by R1 plus 1 by R2 plus 1 by R3. You can take R1, R2, R3 as a LCM in denominator, arrange it, finally you will get this formula. I upon, in numerator, in denominator you will get R1, R2 plus R2, R3 plus R3, R1 into what? R2. Suppose you want to find the current through the R1, you will get R2, R3. R2, R3. So this is the general formula. If you want to find that, this is the formula, directly proportional, then in place of this G1 you can put the 1 by R1 because it is directly proportional to 1 by R1, 1 by R. Right? Arrange it, you will get this formula. To verify it, check करो आंसर सेम आ रहा है या नहीं आ रहा है, yes or no. So now I am going to verify it. I am going to verify it. For example, if I want to find the I1, quickly I will write the equation. I1 is equal to I30 multiplied with R2 and R3. R2 and R3, 3 into 6 divided by R1, R2, R2, R3, R3, R1. Now check. 30 into 3 into 6 divided by 6 plus 18 plus 12. That is what? 18 plus 12, 30, 36. 15. Tell me, 15 was the answer, yes or no? 15 na, current through the R2 2 ohm resistor is 15 ohm. So what we have done, total current multiplied with the R2 R3 upon R1 R2 plus R2 R3 plus R3 R1. Ye. Now second, once you have the denominator, what is the value of the denominator? 36. Then it will become very easy. What is the I2? I2 is nothing but I multiplied with R1 R3 upon same thing. R1 R2 plus R2 R3 plus R3 R1. Right? So just remove the R2 and then multiply these two. So it will become 30 into 2 into 6. Already we have the denominator 36, 6, right? This is 3 and 30 by 3, this is the 10. You will get the 10 as the answer. 10 as answer. At the end, if you want to find the I3, क्या होगा formula बोलो जरा. What is the I3? What will be the I3, guys? Remember, I3 then I multiplied with R1 R2. Remove the R3 upon denominator will remain same. Denominator will remain same. Then I30 2 into 3 divided by, already we have the idea 36. This is the 6 divided by 6. You will get the answer 5 ampere. This is the 3 into 2, 6, 36, 6, 30 by 6, 5. Okay. Tell me, both the methods are clear to you? Crystal clear? How we are getting this formula? Because it is directly proportional to 1 by R. It is directly proportional to G. directly proportional to G. So you can also apply the current division rule in 3 registers, but you have to use this formula. You have to use this formula, or otherwise you can find the parallel combination of those 2 registers and then you can use this method. Both the methods are correct. Okay, tell me how many students use this formula? Parallel combination of the register. Tell me. Jaldi se likho. Yes, I have used this method. Method 1. This is called find the parallel combination of those 2 registers. Then voltage division rule. Again, use the voltage division rule. Second time. This is called method 1. अरे कुछ तो कमेंट्स लिखो. M1, M2. How many students have solved this like this? Method 1. Okay then. Or this is the method 2. This is wrong method ना. This is wrong. ये wrong है ना. ऐसे मल्टीप्लाई करके ऐसे मल्टीप्लाई मत कर देना. This is wrong. Then that is the case. Conductance. Directly proportional to what? Conductance. You can use this formula. This is method. How many students use the method 2? Tell me. Okay. Then. Now, method 3. Method 3 is very simple. What is the method 3? What is the parallel combination of 2, 3 and 6? This is called what? R equivalent. So this is the 3 and 6 parallel is 2. That is equal to what? 1 ohm. This is the parallel combination of these 3 resistors. So this is the 30 ampere. This is the 1 ohm. So what is the voltage actually here? You can say voltage is equal to current into R equivalent. That is the 30 volt. 30 volt. Right? In a parallel, the voltage will remain same, 30 volt. So at this point, the voltage is 30 volt. Now you can directly find what is the current through the I1. Current 30 divided by 2, 15. What is the I2? 30 divided by 3, 10. What is the I3? 30 divided by 6, 5 volt. So tell me, this is the method 3. Tell me, among these 3 methods, which one is the easier one? So directly I have find the R equivalent voltage and then V divided by R1, V divided by R2, V divided by R3. We can find the 15, 10 and sorry, ampere, not volt. It is in ampere. It is in ampere. So this is the method 3. Ampere, yes. This is not in volt, ampere. Is it clear? चलिए क्वेश्चन बनाते हैं. अब बहुत सारे क्वेश्चंस बनाने हैं. Now watch this. Find the value of current I in the circuit of given figure. ठीक है. आपको I find करना. Find the value of current I in the circuit of given figure. What is the value of I? Here it is a I. First method quickly I am going to solve. First method है R equivalent. What is the parallel combination of 20 and 5? 4. What is the parallel combination of 15, 15, 15? 3. 15 divided by 3, 5 ohm. Because 3 resistors are equal. What is the parallel combination of 24 and 8? 6 I think. 24 into 8 upon 24 plus 8. So 24 into 8 divided by 32. 8 into 32, that is the 4, plus this is the 6 ohm. So you can directly solve. This is the 80 volt. This is the 12. Parallel combination 4, 5. This is 5 and this is what? 6. What is the total resistance? 12 plus 4, 5, 5, 10. 12 plus 4, 16. Or 16 or 10. 26 or 6. 32. Am I correct? Then you can find. (2.5 ampere). Very easy. Very, very easy question. 2.5 ampere. Okay, one method to solve this question. Second method, easy है, but just practice, just for practice, current division rule. Watch this. Always remember, suppose you want to find, this is the second method. First method is what? R equivalent. I think this is very, very simple question. Find the R equivalent. Total R equivalent is 32 and therefore the current is what? What is the current given by the battery? 32. This is the value. So you can add and you will get the answer 2.5 ampere. R equivalent you can find. Second method, watch this. This is the current I. I is divided into two parts. But if you have the fast calculation, very fast calculation, it is the total 25. I divided by 25. If you want the current through the 5 ohm resistor, it is multiplied with the 20. If you want the current through the 20 ohm resistor, it is multiplied with the 5. That is the I by 5. So quickly you can divide. You have to practice it. This is the I by 5. Right, this is the I by 5. 20 ohm resistor I by 5. So what is this? 4I by 5. Simple division. 4I by 5. Now again it will become I. It is divided into two parts. Incoming is equal to outgoing and outgoing is equal to incoming. Again it is I. Now these three resistors are same. So what is the current here? I by 3, I by 3, I by 3. Again it will become I. Again it will become I. Now this current is divided into two parts. So what is the current through the 24 ohm resistor? I is equal to, this is the Ix is equal to I divided by 24 plus 8 into multiplied with the 8. Then it will become I divided by 4. Because it is a 32 and I divided by 4. So that current will become 3I by 4. Remaining will become 3 by 4I. And this is the I by 4. So this is called current division rule. Okay, quickly. Now you can write a KVL here. Now you can write a KVL from this point to this point to this point to this in one closed loop. One closed loop. So when I am writing the KVL, this will become minus 80. This is the minus 80 plus 12I, 12 into I plus 20 into I by 5 plus 15 into I by 3 plus 5I plus 24 into I by 4 is equal to 0. Now it will become 12 plus 4 plus 5 plus 5 plus 6 into I, common I is the common, is equal to what? 80. Then 12 plus 4, 16 plus 10, 26, 32I, 80. I is equal to 80 divided by 32. That is nothing but 2.5 ampere. Again we are getting the same answer. Again we are getting the same answer. So what I have done? Current division rule. Or now I have idea in each component what are the currents. For example, in each element what is the current? I by 5, directly I can say 2.5 by 5, that is the 0.5. 0.5 here, 2 here. 0.5 here, 2 here. What is the current? 2.5 divided by 3, 2.5 divided by 3, 2.5 divided by 3. What is the current here? 2.5 divided by 4. So directly I can find the current through any element, and that is called what? Current division rule. Okay, तो देखो भाई, in a written examination it's up to you. In a written examination you can use this method, current division, or what, R equivalent, because R equivalent method is easier than this. If you have to find the I, then R equivalent method is easy. एक बार में आ गया, वन स्टेप सॉल्यूशन 2.5 एम्पियर. ये थोड़ा सा लंबा है, लेकिन अगर इंटरव्यू में पूछता है, इफ दे विल आस्क इन इंटरव्यू, if I want to find the current through the each element, then which method is more suitable, then you can say, sir, current division rule. Current division rule is more suitable for this. Directly we can find the current through each elements. What are the currents? Okay. Now I think now it is clear to you. अब देखो इसरो में क्वेश्चन कैसा है, देख रहे हो आप, ये this was the question in ISRO examination. In a current division rule, that is the question from ISRO examination. Tell me what is the answer. The effective resistance faced by the voltage source is. What is the effective resistance faced by the voltage source? यार क्या बोल रहा है क्वेश्चन? रीड क्वेश्चन केयरफुली. व्हाट इज द इफेक्टिव रेजिस्टेंस फेस्ड बाय द वोल्टेज सोर्स? तो व्हाट इज द इफेक्टिव रेजिस्टेंस फेस्ड बाय द वोल्टेज सोर्स? हियर इज ओनली द वोल्टेज सोर्स. यू हैव टू फाइंड द आर इक्विवेलेंट. व्हाट इज द इफेक्टिव रेजिस्टेंस फेस्ड बाय द वोल्टेज सोर्स? तो फर्स्ट ऑफ ऑल you have to find the value of R, then you have to find the value of parallel combination of R and 4. What is required here? Parallel combination of R and 4. You are giving the value of R actually. This is the question. R parallel with 4. So remember, within a 1 second, within a 10 second, we can solve this question. What is the effective resistance seen by the voltage source? So no need to find the value of R. Tell me, when the something is parallel with the 4 ohm, something is parallel with the 4 ohm, what will be the result? Less than 4. It doesn't matter what is the value of R. Something parallel with the 4, it is always less than 4. Which answer is less than 4? Tell me. Which answer is less than 4? Only one answer is less than 4. 3 ohm is the answer. Is there is any need to find the value of R? Tell me. No need to find the value of R. R parallel, 4 parallel with something is always less than the 4, because when we are connecting in parallel, the value of resistor will decrease. तो होता क्या है, जब भी आपका कोई दो रजिस्टर पैरेलल में कनेक्ट होता है ना, तो उसकी वैल्यू जो है जो दोनों में से कम है उससे भी कम आएगी. तो आपको जरूरत ही नहीं है कैलकुलेशन करने की. हाँ, लेकिन अगर आप कैलकुलेट करना चाहते हो तो ये देखो, अगर यहां पर आप देखते हैं, देखो जरा, यहां से अगर करंट जा रहा है I/4, तो यहां से जो करंट जाएगा दैट इज व्हाट 3I/4, बिकॉज I/4 एंड 3I/4 विल बिकम I. तो I minus I/4 इज द करंट हियर. I minus I/4, that is the nothing but 3I/4 is the current here. Now both have the same voltage, and that's why you can write R into I/4 is equal to 4 into 3I/4. Okay, this 4, this 4, this I cancel, and what is the value of the R? 12 ohm. What is the value of R? 12 ohm. Once you have the value of R 12 ohm, then what is the parallel combination? 12 parallel with the 4. That is the 3 ohm. This is the correct one. This is the correct one. Or you can say, sir, I have used the current division rule. So what is the, according to the current division rule, what is the current here? I/4. So what is the current through the R ohm resistor? Total current divided by 4 plus R. Total current divided by 4 plus R. If you want to find the current here, multiplied with the 4. So it will become, this is the 4, this is the here, 4I plus RI, 4i plus ri is equal to 16i. Now you can find that this is the I common, cancel out, and what is the r is equal to 16 minus 4, that is equal to 12. This is another method. This I, that I is cancel out, and you can find the value of the r, that is the 12, and directly you can give the value 4 parallel with the 12, that is the 3 ohm. So there are different methods, first, second or third. You can use any method. Any method you can use, guys. Is it clear? This is also clear to you? चलिए बनाइए नेक्स्ट क्वेश्चन. ओके, अब आते जरा वो वापस उस क्वेश्चन में. हाँ, नाउ यूज द करंट डिवीजन रूल, फाइंड द वैल्यू. जल्दी से बताओ. हाँ भाई, क्या है आंसर? बोलो. चलो, बहुत दिन से दोस्त वगैरह पूछ नहीं रहे थे तो अब पूछने लगे हैं. दोस्त हैं, पेरेंट्स हैं कि क्या हो गया भैया. ऐसा हो जाता है कभी कभार, हाथ फ्रैक्चर हो गया. देखो उंगली पर, मैं आपको पढ़ा कर गया था, मैं दिखाने गया, एक्सरे करवाया तो पता चला कि थोड़ा सा क्रैक हो गया. तो भाई खेल लेना, कूद लेना, थोड़ा सा एग्जाम के समय में अवॉइड करना थोड़ा, राइट? तो चलेगा. आप देखते हैं क्या पूछा है. फॉर द नेटवर्क फिगर फाइंड द करंट, वोल्टेज एंड पावर एसोसिएटेड विद द 20 किलो ओम रजिस्टर. अभी देखो, सबसे पहला काम, यहां पर मुझे करंट निकालना है. तो मैं करंट निकालूंगा, तो करंट के लिए ना करंट डिवीजन रूल लगा लो. तो व्हाट इज द करंट डिवीजन रूल? व्हाट इज द करंट एंटर इनटू दिस 0.01 V नॉट. तो ये हो गया करंट 0.01 V नॉट इनटू अपॉन 5 plus 20. If you want to find the current, then multiply it with the 5. So it will become 0.01 V naught upon 25 by 5, that is the 5. So that is the answer, current. Now, what is the V naught? So V naught is a simple 5 milliampere multiplied with the 10 kilo ohm. This is the current. So V naught is equal to 10 into 10 to the power 3. This is the kilo ohm. It is the milliampere. 10 raised to power minus 3. This is cancel out and it will become 50 volt. So always remember, guys, no need to write that, because kilo ohm multiplied with the milliampere cancel out, and always directly you can write 5 into 10, that is the 50 volt. But always careful, kilo is cancelled with the milliampere, then no need to write 10 to the power 3, 10 to the power minus 3. It is a 50 volt. So normally in case of analog, current is represented in milliampere and voltage is represented in what? Kilo ohm. Voltage is represented in kilo ohm. Resistance is represented in kilo ohm, current in milliampere, and voltage in volt. Voltage in volt. So this is the 50. So this will become 0.01 into 50 divided by 5. This is the 0.1 ampere. So how many students got the 0.1 ampere? Bilkul sahi, 0.1 ampere. Now once you have the current 0.1 ampere, then you can find the voltage. So what is the voltage across the 20 ohm resistor? Multiplied with that, I into 20 kilo ohm, 10 to the power 3, because it is in ampere. Remember, it is in ampere. So 0.1 into 20 into 10 to the power 3, it will become 2000 volt or 2 kilovolt. 2000 volt or 2 kilovolt. That is the correct one, 2 kilovolt. And now the power. Power is V, voltage across this resistor into current. I into power. V into I. What is the power associated with that? 2000 multiplied with the 0.1, and that will become 200 watt. 200 watt or 0.2 kilowatt. 200 watt or 0.2 kilowatt. बिल्कुल सही है, 200 watt That is the correct one. Not 0.2 milliwatt. That is the 200 watt. Or you can also find the power. Once you have the current, you can also find the power by using I square R. If you want to find the power across that, you can say I square R. So what is the I square? 0.1 square into R, 20 into 10 raised to power 3. So this is the 0.01 into 20,000. Again you will get the 200 watt. Or you can also find the power V square by R. So what is the V square? 2000 volt into 2000, square of that upon 20,000. This two is cancel, again 200 watt. So all the formula verified. You can find the power by using I square R, you can find the power by V square by R. So this is the V and this is the value of R. Or you can find the power V into I, 200 watt. I think this is clear to you. तो ये है V naught dependent sources. This voltage, this is a nothing but voltage controlled current source. It depends upon the voltage across this resistor. Voltage across this resistor, guys. Now, find the V naught in the circuit in figure and the power absorbed by the dependent sources. What is the power absorbed by the dependent sources? Power absorbed by the dependent sources, guys. ठीक है? What is the power absorbed or delivered? It depends. तो देखो. Now, what is given here? Find the V naught in the circuit in the figure and find the power. Okay. कैसे निकालोगे? Tell me. ध्यान देना, जब बोला है ना व्हाट इज द पावर एब्सॉर्ब्ड बाय द डिपेंडेंट सोर्सेस, तो रिमेंबर दिस इज द डिपेंडेंट सोर्स, एरो इट इज गिवन 2 V naught, राइट. इफ द करंट enter through the minus leaving the plus, it will deliver the power. Or if the current enter through the plus leaving the minus, then it is absorb the power. Simple logic, already I have given. If there is any element, this is plus, this is minus, this is V. If the current enter through the plus leaving the minus, we can say absorb the power. Power absorbed. Or in second case, if this is minus, this is plus, if the current enter through the minus leaving the plus, then we can say power delivered. Power delivered. So first we have to find the value of the V naught so that you will get the value of the current, and you have to find the voltage across the V naught. Voltage across this current source. Voltage across this current source. Now how we can solve this question? Watch this carefully. First, this is the V naught, okay, no problem, this is the V naught. Let this voltage is Vx. Let this nodal voltage is what? Vx. Now guys, I am using the voltage division rule. What is the value of the resistor? 10. What is the value of this resistor? 10. If it has the V naught voltage, definitely it also has the same voltage V naught. But remember the polarity. This is V naught minus plus, then it is also V naught. Why? Because the value are same. V naught, V naught. Now watch this. What is the value of the Vx? Minus V naught minus V naught. That's why it will become minus 2 V naught. The voltage at this node will become minus. Let this is the reference. Why minus? Because it is minus, it is minus, it is become minus 2 V naught. Why it is V naught? Both the resistor are same. Voltage division rule, the resistor will remain same. Now it is the minus 2 V naught voltage at this point. Now you can apply what? KCL. KCL. What is the incoming current? 25 ampere. What is the incoming current? 2 V naught. What is the outgoing current? Suppose you want to say that what is the outgoing current, or you can also give the incoming current. For example, let this is the incoming current I here. Incoming current I here. So you can directly say what is the incoming current. Current enter through this, leaving this. So you can say I is equal to V naught upon 10. This is the plus minus. So I, what is the incoming current? V naught by 10. So you can third incoming current. This is incoming. This is incoming. This is also incoming. V naught by 10 is equal to 0. Now it will become 10 as a LCM, 250 plus 20 V naught plus V naught is equal to 0. So you can say V naught is equal to minus 250 divided by 21. V naught is equal to minus 250 divided by 21. So clear, this is the value of the V naught. You can find the value of the current 2 V naught. And what is the voltage from this point to this point? This is the Vx. So this is the minus put here. Simply remember one thing. If suppose I am considering the Vx like this, the current enter through the minus leaving the plus. That's why the general formula for the power, very very important. Current enter through the minus leaving the plus, enter through the minus leaving the plus. This is the minus. This is the 2 V naught into what? Vx. According to the notation, it is that power delivered. No problem. If you are getting the minus value, power delivered. If you are getting the plus value, power absorbed. So polarity minus Vx into what? 2 V naught. Now put the value. So minus 2 into what is the, this is also, what is the Vx? What is the Vx? Minus 2 V naught. So minus 2 V naught multiplied with the 2 V naught. So it will become 4 V naught. Now it becomes the positive. At the end again it will become negative. Why? 4 V naught means minus 4 into 250 divided by 21. At last we are getting the negative value. So tell me, it is absorbed or delivered? It is absorbed or delivered? कहीं भी कोई डाउट है तो बताइए. Any doubt? अच्छा, one student asked, explain the power again. In which question power again? Delivered, na? Yes. In which question power again, Shobna? In which question? Jaldi बताइए जरा. This one, na? This current question. Okay. Okay, 1 minute. You can check my calculation, but what I want to say that simply in this diagram, right? Always remember, in particular element, this is plus, this is minus, this is V, this is I. So we are just writing P is equal to V into I, positive value. So this is called power absorbed. Power absorbed. Or if this is the case, this is minus, this is plus, current entered through the minus leaving the plus, then we can say power is equal to minus Vi, or if it is negative then we can say delivered. But if you are using this formula, at the end we are getting the positive value, means it is absorbed. At the end you are getting the negative value, then it is called delivered. Now, for example, just I am generalize it, I am taking the Vx as a voltage across this voltage, here voltage Vx. So it is negative, current enter through the negative leaving the positive. So which formula is applicable? Second formula. Because current entered through the negative leaving the positive, that's why we are saying that in generalized term, what is the power? Minus of Vx into what? 2 V naught. 2 V naught, this is the power. Okay. Now we have to find the Vx and V naught both. So just to find the Vx, so let this voltage is what? Vx. Okay. So you can apply Vx, you can find. So first of all, just remember, if this is the V naught, what will be the current through this element? V naught by 10. Directly you can write V naught by 10. What is the incoming current? 25. What is the incoming current? 2 V naught. So simple, write down the KCL. तो वही मैंने लिखा है KCL. This is the V naught by 10 incoming current. Plus what? 25 incoming current. Plus what? 2 V naught is the incoming current is equal to 0. And finally, check my calculation. I have done this calculation. So we have solved this. So 20 plus 21 or 250. So 250 divided by 21. This is the answer. This is for V naught. This is for what? V naught. Right? 250 divided by 21. What is the value of the V naught? Negative. Okay. Now what is the value of the Vx? So Vx is, you can write the KVL here in this loop. So when I am writing the KVL, this will become V naught. Right? Watch this. This is the V naught plus V naught. This is the plus V naught. Watch this. Plus V naught plus V naught. This is the plus Vx is equal to 0. So what is the Vx is equal to? Minus of 2 V naught. Minus of 2 V naught. So if the Vx is minus of 2 V naught, if you are putting the minus, so minus minus, this will become plus 4 V naught. Now finally, if you are giving the negative value here, it will become what? Negative of that. So yes. Okay, now it is clear. Vx in reverse direction, no problem. Again you will get the answer. Okay, if you want to take the in reverse direction, no problem. Same calculation, no? Same calculation. Suppose, like for example, in this particular question, you are taking the Vx in the reverse direction. Last your doubts, I am giving the answer for your question. For example, in this question, you are taking the Vx in reverse direction. No problem. 1 minute. Now, according to this, current entered through the plus, leaving the minus, and that's why this will be the formula. Are you getting my point? This will be the formula. Okay, no problem. Now, watch this. Just to find the V naught, the calculation will remain same. What is the incoming current? This is the incoming current. You are getting the same answer, minus 250 by 21. Now, here the change in the calculation. Here the change in the calculation here. If you just want to change the polarity, no problem. So what is the, now watch this. This is the Vx now. You have changed the polarity here. Now tell me, this is what? V naught. This is V naught. This is V naught plus V naught. What is this? Minus Vx is equal to what? 0. So what is the Vx is equal to 2 V naught. Vx is equal to what? 2 V naught, not negative. This time it is positive. This is the minus, this is the plus V naught minus Vx. You will get the 2 V naught. Put here 2 V naught. You will get what? 4 times of V naught, same answer. What is the value of V naught? Negative. So you are getting the answer what? Again, negative. So if you are getting the negative value, means the power is what? Absorbed or delivered? Tell me. Tell me. Because Vx is equal to what? 2 V naught. So you are getting the Vx is equal to minus 500 divided by 21. So if you are getting the negative value, means you have to change the polarity. You have to change the, okay. You have to change the polarity of Vx, and what is the V naught again? V naught is also negative. Then tell me, guys. Yes. Tell me. Yes, yes, yes. If suppose I am going to change the polarity of Vx, I am also change the direction of the V naught, then what will happen? That is a good question. Okay. अब देखो at the end क्या हो रहा है? At the end, suppose we are getting the value of V naught. Value of Vx is equal to, this is correct, plus 2 V naught. 1 minute. Okay. The value of V naught is equal to Vx is equal to 2V naught minus 500 by 21. Right? What is the value of the current? This is the 2V naught. वो भी negative. This is the negative. This value of the current. 2V naught. Not try to understand. 2V naught. So this is the current. Negative. Right? Minus 250 divided by 21, that is also negative. Now we have to change. Suppose you are representing like this. This is the value of Vx, and we are getting the value of Vx is equal to this one. Okay, 500 by 21. And value of this current we are getting the 500 by 21 negative. So actually we can represent it in a reverse direction. Actually, if current is flowing in this direction, it will become positive. And we have to change the polarity of that. We have to change the polarity of that. This will become positive value. Now tell me guys. This is the final answer. So tell me, what about the power? Absorbed or delivered? Now tell me, what is the power? Absorbed or delivered? Because we have find the current as well as we have find the voltage. We have arranged it. When we are arranging it, both are what? We are changing the polarity of that. This is the plus and minus. This is the plus and minus. So what about this? तो हम लोग का कैलकुलेशन देखो जरा, यहां पर आया था Vx इज इक्वल टू, एक मिनट रुकिएगा, पहले वाले क्वेश्चन में हमारा Vx इज इक्वल टू आया था माइनस 2V नॉट. तो माइनस माइनस, अच्छा मैंने यहां पर कैलकुलेशन मिस्टेक क्या कर दी. ओके, और दिस विल बिकम प्लस. पुट द वैल्यू हियर. Then again we are getting the same 500 by 21, right? Okay, and that will be the negative. Yes, power not delivered, power is what? Absorbed. This is clear to you everyone? There is no confusion. Just last one, focus on this. The value of Vx is negative, then change the polarity guys. Change the polarity of the current, so change the polarity of the voltage as well as change the direction of the current. And finally, if the current enter through the plus leaving the minus, you will get the right answer here guys. Okay then. चलो बताओ भाई. अरे अभी भी किसी को डाउट है तो पूछिए. This is the time for assignments. Tomorrow again we will solve more and more question guys. The voltage V in the figure always everyone get the sufficient time. Again solve this question with these methods. I will upload the PDF. If there is any doubt then you can ask me. There should be no confusion, no? Because of the polarity we are getting the different types of answer. So just please check. It is what, if you are getting this, power delivered, otherwise power absorbed. Then already we have, this is the assignment. This is the another one good question. I think it is from again from ISRO. Tomorrow, first of all, we will solve the assignments, then we will enter into the other questions, guys. Okay? Then This is the question from this is a good question. Current division rule. This is a current division rule. I will upload the PDF. Okay. Or yesterday I have given you the assignment. Please solve all those questions. And then tomorrow, first of all, we will solve question and then we will enter into the next topic. Okay. 1 minute. This was the question. But try to solve. This is the question from the ISRO. This is the another assignment. Now you can solve. We have the idea about the KCL, KVL, current division rule, source transformation. Then you can solve. Now you have asked question. Sobna, now it is clear to you? Everything is clear? This is another assignment. This is the question in ISRO examination, right? For a circuit shown below, calculate the value of I1. So again, this type of question. ये ISRO का है ना, previous year question. ये बैटरी है प्लस माइनस 10 वोल्ट. दिस इज द प्लस, दिस इज द माइनस, दिस इज द प्लस, दिस इज द माइनस. 10 वोल्ट, 20 वोल्ट. This is the current source 10 I1. This is the I1, or this is the plus and this is the minus 0.7 volt I1, and this 10 kilo ohm, 10 kilo ohm is connected, 1 kilo ohm, and this is the current source is connected. You have to find the value of I1. You have to find the value of I1. ये इसरो में आया था क्वेश्चन. ओके, ये भी है क्वेश्चन जो इसरो में आया था, तो ये चेक कर लेना. वैल्यू ऑफ द कैपेसिटेंस. What is the equivalent value of the capacitor seen from this terminal? Okay then, ये होमवर्क है भाई, सब सॉल्व कर लेना. फाइनली थैंक यू. अब कैसा लग रहा है? अब देखो, मैं लास्ट पॉइंट बोल दूं. ये क्वेश्चन डायरेक्ट आए या नहीं आए, बट यू हैव टू गेट द कमांड ओवर KCL, KVL, वोल्टेज डिवीजन, करंट डिवीजन, पावर डिलीवर्ड, पावर एब्जॉर्ब, आर इक्विवेलेंट, वोल्टेज डिवीजन, करंट डिवीजन. अगर ये आपकी कमांड है ना, तो आपसे आगे ना बहुत नेटवर्क इजी हो जाएगा. क्वेश्चंस अच्छे आते हैं थ्योरम से, ट्रांजिएंट से, लेकिन जब तक आपका ये बेसिक ही नहीं बन रहा है, आप सिली मिस्टेक्स कर रहे हो, प्लस माइनस की गलती कर रहे हो, तो फिर आपको दिक्कत होगी. तो आप इसको बना लीजिए इजी एकदम. 2+2, जैसे मैं पूछूं 2+2 क्या है, बोलो 4. अगर मैंने कोई सिली मिस्टेक की तो आप बता सको सर यहां पर आपकी मिस्टेक हो रही है. कोई दिक्कत नहीं, कैलकुलेशन मिस्टेक हो सकती है. तब आपको फिर लगेगा ओके. अब जब बेस अच्छे से स्ट्रांग होगा ना, तो आप इंजॉय करेंगे सब्जेक्ट्स को आगे. इसीलिए क्वेश्चन खूब बनाओ, बेसिक्स पर क्वेश्चन खूब बनाओ. इफ कोई स्टूडेंट नया है, आप अभी प्रिपरेशन स्टार्ट कर रहे हो, तो सॉल्व नंबर ऑफ क्वेश्चंस फ्रॉम वेरियस टेक्स्ट बुक. यू कैन सॉल्व द क्वेश्चंस फ्रॉम साडिकू और एनी अदर टेक्स्ट बुक. First get the command over these topics: KCL, KVL, mesh analysis, power calculation, charge, current distribution, voltage distribution. Okay, तो बाकी फिर आपकी जर्नी बड़ी स्मूथ हो जाएगी. Okay then, thank you, have a nice day. और असाइनमेंट्स पूरे कीजिएगा और लास्ट शॉर्ट नोट्स, फॉर्मूला नोट्स जरूर बनाइए. थैंक यू.